Hello everyone, thank you for joining us today for Odor Control with Permanganate webinar with our speaker Darren Scott with CARUS. I'm Ashley Swingle, Marketing Specialist, also with CARUS. A few housekeeping items before we get started. We are recording this meeting and everyone is kept in listen-only mode. If you have questions, we encourage you to submit those throughout the presentation using the question pane in the GoToWebinar panel or email us directly. If you submit questions through GoToWebinar, we will receive a report with your question and contact information to follow up directly after the webinar. If you're interested in receiving a PDF or recording of the presentation, please contact us. We encourage you to share the recording within your network. Listed here are a few ways to find us. We have our website and general sales and marketing email address, as well as my email address. Do you receive our email blasts for upcoming webinars, presentations, trade shows, and technical information on our various solutions? If not, sign up on our website. You can find the Join Our Email list on any of the landing pages on the right-hand side. Be sure to select the industry when signing up to ensure you receive the most targeted information for your needs. And we can't forget to mention our social media platforms. We encourage you to connect with our CARUS page as well as our team members on LinkedIn, where we're often sharing upcoming events, including webinars, industry articles or news, sharing relevant posts from other industry experts, and more. Listed here are links you can visit for upcoming webinars and also our website. At this time, I would like to take the opportunity to introduce our speaker, Mr. Darren Scott. Darren has worked for CARUS for over 20 years. As the technical marketing specialist, he conducts laboratory testing and product demonstrations for CARUS municipal, industrial, and environmental customers and prospective new customers. These product demonstrations include technical training, safety presentations, and installation of safe chemical handling and dosing systems. He is a graduate of Illinois Wesleyan University, Bloomington, Illinois, with a Bachelor of Science degree in Chemistry, ACS certified. Mr. Scott is a member of AWWA, Water Environment Federation, and the American Chemical Society.
Good afternoon, everyone. So a brief outline of the presentation we're going to go through. We're going to talk about odor control. We'll talk about both collection systems and in the wastewater treatment plant itself. We'll talk about how to go about conducting an odor survey, the different treatment options you have, depending on where you're treating for odor, and case studies for each of those application points. So one of the first things you should think about is when you get asked about an odor complaint is what type of odor are they experiencing? Is it being formed in the distribution system? Is it being formed in the plant? Where exactly do you have those odor issues? What are the reasons why you're looking to treat it? It could be as general as worker safety, which is very important, or it could just be nuisance complaints from neighbors near the plant or near that part of the collection system. And then what are your options you can do? There's maybe some simple things you can do to maybe eliminate some odors at different parts of the plant by just moving the wastewater or getting the sludge through the plant quicker. But obviously, if you can't do that, then there's some things you can do for odor control that are chemically based. When we talk about a wastewater system, there's a lot of moving parts and it's a very large system. You can be out in the collection system where you can have pump stations and force mains and gravity sewers, which are all different parts where you may have to do treatment. And the treatment may vary depending on where you're at in the collection system. You might have the ability to stage equipment and a pump, or you may need to have everything below the manhole cover or below the wet well cover, so you can't have anything exposed to the environment. At the wastewater treatment plant, obviously you have the headworks where you might have some odor issues, but a larger source of odor is typically farther back in the process where you're doing sludge dewatering on a belt press or a centrifuge prior to you trucking the sludge off to a landfill or for land application. The general issues that most plants experience are going to be nuisance odors. So they're going to have hydrogen sulfide and mercaptan odor issues from that process. You may see some general equipment corrosion. Hydrogen sulfide can be very corrosive to both concrete and metal in the area. So if you're getting a lot of off-gassing of hydrogen sulfide, you can see that the concrete might be corroded. You might see rusting of the metal in those facilities around those high levels of hydrogen sulfide. And then in the collection system, you might see issues at pump stations, lift stations with grease removal, where the grease accumulates around the floats. Now, it's odd to talk about what type of odors you may just encounter in wastewater, but sometimes they can tell you that you've got different compounds than the traditional ones. If you have an organic kind of smell that smells skunky, it's going to be some type typically of mercaptan-based odor. You can have other things like fishy, which would be nitrogen compounds. Obviously, depending on the type of wastewater you're treating, you might have an ammonia smell, which would be ammonia compounds. You could have fecal, decayed flesh, all sorts of different types of odors that you may encounter. Generally in wastewater, when you have one of the odor odors, it'll typically be based around an industrial discharger or something else out of the ordinary that's being discharged to the wastewater that the bacteria are converting to these interesting odor compounds. Depending on what type of compound that you have, there can be a very, very low odor threshold for people to smell it. Most mercaptan compounds, as you can see here on the list, have parts per million levels of multiple zeros where you can still actually smell them. One of the other things about mercaptans as well is a lot of people will claim that it clings to them. So if they're around an odor source that's generating some mercaptan, when they leave the area, they'll still be able to smell the mercaptan slowly over time as it comes off their clothes and out of their hair. One of the major compounds that we'll talk about is hydrogen sulfide, which still also does have a very low odor threshold and has the very distinctive smell of rotten eggs. So when we talk about wastewater issues, hydrogen sulfide is usually one of the easiest things to measure and usually is the one that's causing the most odor complaints. You may have some of the other mercaptan compounds mixed in as well, but they'll typically be at much lower levels. Some of the other things you want to be concerned about when you're doing an odor survey is you could have other gases that you may encounter. You may have a strong ammonia smell, which can cause your eyes to water. And then you also have to be concerned with the hydrogen sulfide because you might also have it mixed in with carbon monoxide or carbon dioxide or even methane, depending on where you're at. So definitely when you're in confined spaces or areas where there's not a lot of airflow, you want to be concerned because all those different gases can displace oxygen from the air, and so it can be a hazardous environment for you to enter. Like I said, one of the largest compounds that you're typically going to encounter in wastewater is going to be hydrogen sulfide. It's colorless. It has the very distinctive rotten egg odor. So when you first walk into an environment with hydrogen sulfide, you'll definitely get that rotten egg smell. It's water soluble, so a portion of the hydrogen sulfide will be in solution, and then a portion, when it gets stripped out, will go atmospheric for hydrogen sulfide. It's extremely toxic. You're going to see an OSHA chart on what are the acceptable levels to be in the environment when you're around hydrogen sulfide. In addition, hydrogen sulfide can mix with moisture in the air to form sulfuric acid, which is why it can corrode concrete and corrode metal in the application. Depending on how high the level of hydrogen sulfide can get, it can even get into a range where it can be considered explosive. This is the OSHA chart that I was talking about that shows the toxicity spectrum for hydrogen sulfide. As you can see, very low levels, 0.1, 0.2 ppm, are where most people can smell it. Some people can even smell it at lower levels. As you get above that level, between about 3 and 10 ppm, it's a pretty offensive odor. It's going to have a rotten egg smell that's very distinctive. As you get above 10 ppm, some people will claim that it gives them a headache or it causes some nausea. And then you can see as you increase the level of hydrogen sulfide in the area, it can cause eye injury, it can cause respiratory tract irritation, and then obviously if you're above 300 ppm in a confined space, it can cause an immediate life threat. As you can see, OSHA limits you to a 10 ppm time-weighted average during the course of an 8-hour day, but they also allow that you can have a 50 ppm max peak for 10 minutes in an 8-hour shift. But it's something you definitely want to keep track of. So how does that hydrogen sulfide form both in your collection system and in your wastewater plant? Well, one of the things that's always present in your wastewater is a lot of sulfate material. So sulfate plus any type of organic material that's in the wastewater, so our waste from humans, will combine with anaerobic bacteria. And what ends up happening is that anaerobic bacteria start chewing up the oxygen off of the sulfate compounds. As they do that, they release sulfide into solution. And then with any type of turbulence, that sulfide that's in solution can come out as atmospheric hydrogen sulfide. So you'll get that kind of loop in the system. And really it's based on the longer that wastewater sits and you lose all your dissolved oxygen, now the bacteria is looking for another oxygen source, and so the sulfate is plentiful, so they go after that oxygen on the sulfate. Keep in mind that sulfate-reducing anaerobic bacteria, they thrive at low oxidation reduction potentials. So when you don't have any dissolved oxygen, they're going to predominate the biofilms out there in the collection system. Ideally, they like pHs between 6 and 9. So those are the standard wastewater pHs you'll see out in your collection system. So that's a perfect environment for them. Wastewater is always warm. So they have the nice warm temperature to keep them respirating and chewing up the sulfate to generate hydrogen sulfide. So you have a perfect environment both out in the collection system and in your plant. As that wastewater sits, you'll chew up all your dissolved oxygen, and the bacteria are in a perfect environment to generate more and more hydrogen sulfide. In the collection system, what that looks like is the picture that you see here. You have the pipe wall with a biofilm/slime layer growing on the side of the pipe. Depending on the type of part of the collection system you're in, you can have some water on the bottom part of the pipe and an air interface above it. What ends up happening is, as you lose dissolved oxygen in the wastewater itself, the bacteria start switching from oxygen to that sulfate and start generating hydrogen sulfide in solution. That turbulence then, or just the amount of hydrogen sulfide that's in solution, eventually some of it will go atmospheric as it's an equilibrium. So some of it will slowly bubble out of solution. So now you get some hydrogen sulfide in the air in that pipe. It interacts with the moisture on the pipe wall, and you generate some sulfuric acid. That sulfuric acid runs down the pipe wall, corroding the top or the crown of the pipe. And then it comes back into solution, and now you've generated sulfate back into solution that the bacteria can chew on again, and then it repeats its cycle continuously. One of the things to keep in mind when you're treating for hydrogen sulfide is it is an equilibrium. So depending on what pH you're at, depends on how much hydrogen sulfide you will have in solution and how much will be atmospheric. As you can see on this graph, between pH 6 and 9, you'll have a portion that's dissolved and a portion that's atmospheric. If you drive the pH below 6, you'll drive almost all the hydrogen sulfide out of solution, so we'll all go atmospheric. If you go above pH 9, you'll trap almost all the hydrogen sulfide in solution as dissolved sulfide, and so it will still be there until the pH drops back down, and then it can be released at a later part of the system. So one of the things when you're doing pH adjustment in a system for odor control is you're typically going to try to target a pH, above 9, somewhere between 9 and 10. But as soon as that pH drops back down, that sulfide is still there. It can be released back into the atmosphere. So you do need to take a consideration of when the pH drops, it's going to come back out of solution. A question we get asked all the time at CARUS is, I only have atmospheric numbers for my hydrogen sulfide. Is that a way that I can tell how much dissolved sulfide I have in solution? Well, the answer is it can give you an idea of how much you might have, but because the hydrogen sulfide in the atmosphere is based on the size of the area you're in and how much is being released, it doesn't really translate one-to-one. So what you can see on this graph, that as the temperature rises, you're going to have more dissolved sulfide come out of solution and go atmospheric. But you can also see, depending on how many parts of dissolved sulfide you have in the wastewater, it can cause quite a bit of variation in how much atmospheric hydrogen sulfide you have. If you don't have a whole lot of dissolved sulfide, say half a part, then maybe you might have 10, 15, 20, maybe as high as 100 ppm of atmospheric hydrogen sulfide. As your dissolved sulfide climbs, though, and that temperature warms up, you can strip a lot more out of solution. So you can see if you get to 2 parts of dissolved sulfide, you can have maybe a low of 100 part or 200 parts of atmospheric, but you can be up around 700 or 800 atmospheric hydrogen sulfide as the temperature warms up. So just having more in solution is going to mean you're going to have more in the atmosphere as well. When we talk about sulfide, one of the easiest ways to remove it and one of the quickest ways to remove it is permanganate oxidation of sulfide directly. So if you have dissolved sulfide in solution, you can add permanganate directly to that wastewater or that sludge, and regardless of whether it's acidic or neutral or basic pH conditions, we're going to oxidize it. What you can see here are all the chemical reactions. A general rule of thumb is we need 2 to 4 milligrams per liter of permanganate for every 1 part of sulfide in solution that we need to react with. So just kind of a general rule of thumb of 2 to 4 parts of permanganate per 1 part of sulfide. One of the benefits of permanganate oxidation is its rapid reaction. As soon as you add the permanganate to the wastewater or to the sludge, it's going to react with the hydrogen sulfide and mercaptan compounds and eliminate them immediately. One of the tests we do in the field is a jar test called a shake test, where we add wastewater or sludge to a jar, we add our permanganate, we mix it for a few seconds, and then we shake it to determine how much sulfide we can strip out of solution. In that test, just a couple seconds of mixing is enough to eliminate all the hydrogen sulfide and mercaptan, and then we'll be able to measure that we've knocked it completely out in those jars. Some of the other compounds you may see for odor control are hydrogen peroxide and iron salts. Typically, both of those compounds need reaction time to remove hydrogen sulfide from the wastewater or from the sludge. So generally, you would feed them way upstream and generally have a contact tank or might have multiple feed points in order to knock the hydrogen sulfide odor down. Whereas permanganate, you can have one application point right at your application point where you need odor control. One of the other compounds that I had talked about earlier are mercaptans. Mercaptans are all those kind of funky odors. So the fishies, the garlics, the other septics that aren't rotten egg. Permanganate also reacts with those very rapidly. What you can see here in the graph is, in this case, we were reacting with a methyl mercaptan compound, and we had about 40 milligrams per liter in solution. We were able to dose it with permanganate and knock it down to less than 1 milligram per liter with permanganate. And it took about 177 parts, because that's an awful lot of mercaptan loading. Peroxide was also able to get it very, very low, but it took 420 parts as active peroxide to get it down to about 2.5. And then iron salts, which generally work the best with precipitating hydrogen sulfide, they're not the best for mercaptan removal. You can see we fed almost 1,500 parts of iron salts, and we were only able to get it down from roughly 35 to just under 25 with the iron salts. So in that case, only the peroxide or permanganate would be viable options, and the permanganate is at a much lower dosage to get rid of the mercaptan compounds. One of the things that you need to do when you're doing an odor survey is you want to systematically collect information about your wastewater system. If you're out in the collection system, one of the things you want to keep track of are what are the flow rates? Do those flow rates change over the course of time? So are they higher in the morning when people are at home and waking up? Are they higher at night when people are taking showers and doing dinner? So kind of have an idea of how your flow rates change over the course of time in your collection system. Where are you getting the odor complaints? Is it from the discharge of a force main? Is it specifically around a lift station or a pump station where you're getting a lot of odor complaints? Is it generally a run of manholes in a downtown area and you're getting complaints from people being out shopping or on the sidewalks? Once you determine where you think those odor issues are, then that's definitely a place to then put some monitoring equipment in and measure the levels of hydrogen sulfide and mercaptans that you have in those areas. You want to take this data and analyze it to make sense of where you're actually going to feed and what's the best treatment that you can do. When you're doing that odor survey, there's a lot of different types of monitoring that you can do. There's many commercially available hydrogen sulfide gas sensors that you can use. A lot of those gas sensors you can actually leave in a manhole or a lift station or pump station, and they'll log data over a week to 2 weeks, and then you can download that and look at the graphs to see when are you getting your major odor complaints. Do they then tie into when you have flow changes in the system based on when people are home? But when are those complaints really happening? You can do some air sampling with Draeger tubes to determine different mercaptan compounds you may have. And then finally, you can measure dissolved sulfide with many different types of dissolved sulfide kits. You can sample the wastewater and do it multiple times in a day to just see if there's some variation. And one of the things you can also do is, because if you have an odor or some type of monitoring, those times where you see higher spikes of hydrogen sulfide in the system, that would be a good time to go out and pull some wastewater samples at that specific times to see if it matches up with high dissolved sulfide readings at that time as well. When you're out in the lift station, one of the things you do want to do is get an overview of the collection system. So specifically, where do they have their odor issues? And then you kind of want to draw a map upstream and downstream of that point where you're having the odor issue. So one of the things you can do is they'll typically have maps of how their collection system is laid out and where everything is. So one of the things you want to keep track of is there a lift station upstream or a pump station upstream that you could stage chemical at? Does it have ability to do power to a pump? What all do you have access to? And then downstream, where are you seeing the odor complaints? Is it just at one manhole, which may be the discharge point for the force main? Is it just a gravity sewer discharge point where you're getting complaints? What is downstream of it? Basically map that out so you can see where you can feed upstream or at the application point, and then what are the issues that you maybe see downstream as well. When we talk about what hydrogen sulfide does in the collection system, I mentioned that the atmospheric hydrogen sulfide mixes with the moisture in the system and generates sulfuric acid. What this picture is showing, you've got the atmospheric hydrogen sulfide generating sulfuric acid, and slowly but surely it's eating out away at the crown of the pipe. So what does that look like in a system? Obviously, you can see two pictures here where you see a lot of corrosion to the metal pipe, specifically in one where you can see actually the whole crown of that pipe is completely eaten away. Eventually, if this gets bad enough in an area, you can actually have a pipe collapse, and then the wastewater will back up from that point farther back into the system. In the past, we've seen this with customers that we've worked with before they did treatment. We were working with a chicken plant in South Carolina, and they actually had part of their sewer line collapse, and the only thing on it was the chicken manufacturing plant. They had to run a new line to get the chicken processing plant back up and running, and then they put in permanent treatment for odor control to prevent a sewer collapse in the future. The other place besides the pipe, which is kind of hard until you have it collapse or if you camera it, is anytime that you flip over a manhole cover out in the collection system, it can be very apparent that you've got corrosion going on. These pictures are from multiple different collection systems, and you can see that the concrete is definitely corroded. You can see that chunks of it look like they've fallen down in the system. And one of the things you want to keep in mind is when you're working one of these systems, a lot of times we hang our odor monitoring equipment off of the rungs that you see in the pipe wall. One of the things you want to make sure is you want to make sure that you grab that rung and kind of tug on it to make sure that it won't pull out of the rug or fall down, because now you're going to hang your monitor on it. So one of the things I always do is when I flip open the manhole and see a lot of corrosion, wherever I'm going to hang the monitor, I'm going to do that double check to make sure everything's solid that I'm attaching to, so I don't lose my equipment downstream if that thing falls out of the pipe wall. There are some things that you can do out in the collection system to prevent the hydrogen sulfide formation. If you can maintain adequate flow velocities, meaning you're moving the wastewater quickly from the homeowner to the wastewater plant, that means you're going to minimize the detention time out there in the collection system. as that wastewater moves quickly to the plant, it doesn't have time to generate as much hydrogen sulfide as it would if it sits for long periods of time at lift stations or pump stations. So one of the easiest things you can do is, can you get those pump stations to run more often? Can you get that wastewater to move quicker to the plant? Sometimes that's not possible because systems are designed for future growth. So some of the pump stations and wet wells might be much bigger than they need to be because they're planning for having more people living in the area in the future. There are still some things you can tweak with flows and levels in those wet wells, and those are things you want to do right off the bat to try to minimize the hydrogen sulfide formation. Another thing you can do is good housekeeping. What you can see in this picture is there's some grease that's kind of collecting in one side of the wet well, and it's collecting over on the side where the floats are as well. Well, if the floats get impacted, the pump station doesn't work exactly the way it's supposed to, and so that can cause issues with the wastewater sitting longer at those lift stations. So one of the things you can do is, if you can eliminate that grease or get it moving through the system quicker, that can help eliminate some odor issues. Another thing with grease is also have a good grease program in your community, explaining how people aren't supposed to dump their cooking grease down the drain and flush it to the wastewater plant. That's just a good idea to make sure that they're not dumping stuff that are going to cause issues for the wastewater plant. Some other things, you can have issues with rags and flushable wipes that can plug up the collection system as well and cause issues at pump stations and wet wells. So also explaining to the customers how flushable wipes really aren't flushable and aren't meant to go down the sanitary sewer because they can cause issues for you. Basically everything to get the wastewater moving through the system as quickly as possible and getting it to the plant. One of the things at CARUS Corporation is we have a lot of different products that you can use for odor control, and they all kind of have a role depending on where you're at out in the collection system or at the treatment plant. They also can be picked based on what's your flow rate and what kind of reaction rate do you need. So what you can see on this chart is we have CAIROX CR permanganate tablets, we have CAIROX nuggets, we have TOTALOX, we have CARUSOL liquid permanganate, and we have CARUSOL plus liquid permanganate. The chart gives you an idea of what kind of products would be recommended based on your application and your flow rate, and then what type of odor are you looking for. Some products don't make sense in certain applications, as you can see as you look through this chart. It's also available in a literature piece, and we'll be sending you the slides if you request them for the webinar. So in the collection system, you have multiple treatment options. You have CARUSOL liquid permanganate, you have TOTALOX odor eliminator, you have CAIROX CR potassium permanganate tablets, and you have CARUSOL plus liquid permanganate. The first product we're going to talk about is CARUSOL liquid permanganate. The product is sodium permanganate based. It's available in a 20% or 40% concentrated solution. And the packages it's available in are 55-gallon drums, 250-gallon bulk IBCs, or in bulk loads, depending on how much you're going to need to apply. The CARUSOL liquid permanganate is a dark purple solution that you see in the bottom picture. And you'll see it available in either the 20 or 40% concentration. You'll use the CARUSOL product when you have an immediate odor issue. You need to knock the hydrogen sulfide down directly at the application point where you're going to be feeding. Our first case study here is a collection system lift station. The lift station was located near a neighborhood and was directly across the street from a soccer park. They were treating about 1.2 million gallons a day of wastewater through the lift station. They were getting some grease issues as well in the wet well, as you can see in the picture where it was collecting on the side where the floats were located. As part of the odor survey, a data logger was suspended in the wet well to collect baseline hydrogen sulfide data. What we found over the course of multiple days was there was an average of about 14 ppm in the wet well itself, and occasional peaks of 80 parts per million. The idea, because most of the odor complaints were coming directly from this lift station, was to do the treatment as the wastewater came into the lift station to eliminate it. So we needed immediate odor control, so we wanted a high permanganate concentration. There was no upstream lift station. Everything that was coming into this wet well was gravity sewer from homes. What they were also doing is they noted that they had to clean the grease out of the wet well approximately every 6 weeks to knock it down and break it up so it could be pumped out so it wouldn't impact the floats in the wet well. They chose CARUSOL liquid permanganate. They had space inside the building to set up two 55-gallon drums of the CARUSOL. And when we did the odor data, we noticed that there was different times of day where they had odor complaints and the flow went up. So the feed system was 2 metering pumps, and they were both on timers. One timer was set to run most of the day, and then the other timer was set to kick up the feed rate and turn on the second pump to vary the feed rate to get a higher dose at those times. Once we did treatment with about 5 gallons per day of CARUSOL to treat the 1.2 mgd, the average hydrogen sulfide in the wet well dropped to 0 ppm, and the peak dropped from 80 to 10. One of the other things they noticed is that they only had to clean the wet well for grease issues 3 times per year instead of every 6 weeks. They also noticed that they had no more odor complaints from the neighbors near the pump station or from people watching their kids play soccer in the park at the soccer field. So it eliminated their odor complaints, eliminated their grease issues all at the lift station where the feed system was located. One of our other products is TOTALOX Odor Eliminator. It uses a small amount of permanganate for oxidation of hydrogen sulfide, and then it uses nitrate salts for the inhibition of sulfate reduction. The bacteria that you have out in your collection system typically would love to chew on dissolved oxygen. Once they run out of dissolved oxygen, if you give them a nitrate source, they'll chew on the oxygen on the nitrate. If they run out of nitrate, then they'll start chewing on the sulfate and generating hydrogen sulfide. So you can eliminate the sulfide reaction by giving them nitrate to chew on. A general rule of thumb with our TOTALOX odor eliminator is that we need approximately 2 to 4 gallons of the TOTALOX permanganate nitrate blend per pound of sulfide to be removed in the wastewater. Our general goal when we feed this product is to try to achieve a dissolved sulfide in the effluent at where we're trying to have odor control downstream of 0 milligrams per liter of dissolved sulfide. As the dissolved sulfide drops up, you'll reach an inflection point at the bottom where you'll have no dissolved sulfide, and then you may see some nitrate residual as it starts to be in the system. The general goal is to have very little nitrate, or depending on if you're trying to contain the nitrate a little farther downstream, maybe through multiple lift stations, is that maybe the first lift station or manhole will have a little bit of dissolved nitrate, and then the farther ones downstream, that level will drop off as the bacteria chew it up, and then eventually you'll have no nitrate going into the treatment plant. Some of the factors that can affect the dosage, if you have really warm temperatures, it may require higher dosages. A lot of times we have systems that feed in the summer months is when they have their odor complaints and they have their most issues. And then when they get into the cold winter months here in the Midwest, they don't have to feed as much, or they don't even have to feed in the winter months. Also, one of the things to keep in mind, if you have longer detention times, so the wastewater is sitting longer in those wet wells for longer periods, or it takes longer to get to the treatment plant, then you might have to feed a higher dosage toward that 4 gallons in order to keep enough nitrate in solution for the bacteria to eat. Our case study here was a southeastern county in the US, and they had a very large wastewater collection system with many, many pumping stations throughout. They specifically had one lift station in particular that was causing many, many odor complaints. The reason was it was near a busy road, and as you can see in the picture, there's the pump station, and located directly behind it is the primary school for this county. One of the things that was an issue is the primary wind direction was blowing from the pump station directly toward the front of the school. So both in the morning and at the end of the day, when people drop their kids off or pick their kids up from school, if there was any type of wind blowing toward the school, they would get a lot of odor complaints because you could smell the rotten egg odor from the pump station itself. The county referred to this as the highway lift station, and it got wastewater from 2 locations. Most of the flow was coming from a force main that was about 100,000 gallons per day upstream, about 3.4 miles up from the school. There was a smaller amount being donated by the school of about 5,000 gallons a day. So when we looked at the 2 sources of wastewater coming into the lift station, most of the odor was all based on the 100,000 gallons per day coming from the upstream pump station, and very little odor was being contributed by the school when it was in session. The initial survey found about 4 to 5 milligrams of dissolved sulfide in the wastewater coming from the upstream pump station. Atmospheric sulfide was as high as 5 ppm leaving the vent at the lift station, and it was greater than 50 ppm in the wet well. You can see the inside of the wet well with the lid open and the green coating. They'd actually applied that green coating because they had to replace parts of the wet well because the concrete had corroded so bad. So in order to prevent that from happening after they replaced it, they put the green coating on it to prevent that interaction with the hydrogen sulfide in the atmosphere. Treatment was begun at the upstream lift station. They placed a tote inside a fence line with a metering pump on top of it. The dosage started at 10 gallons per day, and then the dosage was increased to 15 gallons per day when we were still getting some occasional odor complaints based on the lower dosage of 10 gallons per day. With treatment, the dissolved sulfide levels at the lift station in front of the school dropped to less than 1 milligram per liter. The atmospheric hydrogen sulfide discharging from the vent at the wet well was 0 ppm, and in the wet well itself, we were less than 5 ppm. Once the treatment started at the higher dosage of 15 gallons per day, they got no additional complaints from the school, which was what their objective was. Plus, they knew because there was less hydrogen sulfide, there'd be less future corrosion on that wet well and the equipment located there. Sometimes you don't have the ability to feed at a pump station or a lift station. You may just have a manhole and a gravity sewer with nothing above ground. In that case, you have the option to use CAIROX CR potassium permanganate tablets. The tablets look like the picture. They're a purple hockey puck. They're 80% solid potassium permanganate mixed in with some non-hazardous binders. They're roughly about 2 inches in diameter and about 3/4 of an inch thick. You typically deploy them with the mesh bag that you see pictured on the ground there, and then they're suspended by rope into the wastewater flow. As you can see in that right-hand picture, the wastewater is pouring down, and at the bottom you can see some purple disturbance where the tablets are dissolving. We've done multiple field trials and tests with the tablets to get them right. The idea is you're going to put them upstream of where you're having your odor complaint, suspending them in that mesh bag. And in this case, it was in a downtown area with shops and restaurants to eat at. The tablets you can see were deployed in a manhole just slightly upstream of where we placed the data logger. And the flow rate through this part of the collection system was 100,000 gallons per day. We initially started with 10 pounds of the tablets in that mesh bag, and we measured both the bag weight and the hydrogen sulfide concentrations recorded over time to determine how well they were working in the system. One of the things you can do, because this is such a low-tech application with the tablets, is you can vary how many pounds of tablets you put in the mesh bag. You can also vary how much of the mesh bag is exposed to the wastewater flow. So is only half the bag in the flow, is only 1/4 of the bag in the flow. And what you can do is basically, based on the hydrogen sulfide monitoring you're doing, you can see is there a difference with treatment and how much of the bag and how much poundage do you have in the bag. The blue on this graph is untreated hydrogen sulfide. So what numbers of atmospheric we were getting based on not treating. And then we placed the tablets in the bag and then varied how much were in the bag and how much was in the flow. And you can see where the hydrogen sulfide went to. So in the orange is where it goes away. So you can see as we kind of varied stuff, we were able to knock it down initially. And then as we placed more poundage in the bag and got more in the flow toward the end of the trial, we were able to almost completely eliminate any atmospheric hydrogen sulfide coming out of the manhole at the end of the trial. One of the questions we often get asked with the tablets is how often do I need to replace them? Well, it's going to be dependent on how much of the bag that you have exposed to the wastewater flow. So if you're hanging half of the bag in the flow, it's going to use these a little quicker rather than if you only have, maybe a quarter of the bag or less in the flow. It also depends on, are you seeing a lot of turbulence, a lot of mixing? As you can see in those different pictures, you can have wastewater flow just kind of meandering through the manhole, or you can have wastewater being discharged higher up and then splashing down on the tablets if you have multiple things in that manhole going on. On the low flow side of things, typically we would say if you're under 50,000 gallons per day, probably every 2 weeks-ish, you would have to replace the tablets. If you're somewhere between 50 and 100,000 gallons per day, maybe just over once a week. And if you have a much higher flow up to about a half an MGD, then you might have to replace them once a week. Many systems that use the tablets might check on them weekly just to make sure that they've got tablets in the bag, make sure there's not been any regs that have kind of collected on the mesh bag. So they'll shake the bag on the rope kind of to make sure that they see everything's kind of working well. And do it kind of as a weekly round thing. But it's one thing, since this is so low tech, once you first start the trial, you definitely need to go out and check on them a little more frequently at the start of the trial. And then once you have an idea of what's working best in your collection system, then you can kind of get to a routine of maybe I only need to go once a week or once every 2 weeks to check on them. So as you can see, we have a lot of different treatment options out in the collection system, and it really depends on where the odor is. Well, the same thing is true when we move into the wastewater treatment plant itself. You can be at the headworks where the primary wastewater is coming in. You may have issues with aeration tanks or clarifiers having odor issues, or you may have issues at the back of the plant where you're doing sludge thickening and you're doing sludge dewatering on belt presses or centrifuge. If you look back at that wastewater selection chart, when you get into the treatment plant, at like the headworks or the clarifiers or even the sludge dewatering, then you're generally going to want immediate odor control. And you'll use something like CARUSOL or CARUSOL Plus possibly, or CAIROX nuggets. You won't use a product like TOTALOX because you don't want to introduce the nitrate into the wastewater plant itself, because the bacteria will chew on the nitrate and generate some nitrogen gas, which can cause some of your sludge and your clarifiers to float. So generally, TOTALOX is only ever used out in the collection system. And then when you move into the plant, you're going to mainly focus on permanganate applications. So your options typically are going to be either CARUSOL or CARUSOL Plus. We have had some customers that have used the tablets in the front of the plant. They'll use them in clarifiers. If they're getting some septic odor from a clarifier, they can throw some of the pucks in the clarifier itself and they'll sink. But we also have customers that will also use the nuggets as well, which you see on the right-hand picture. They're smaller chunks of permanganate. They won't sink as fast, so they'll react more as they sink into the clarifier. So we have customers that will apply them to clarifiers as well. So our first application here for odor control is going to be for CARUSOL liquid permanganate. And the background was the wastewater treatment plant had a lot of issues with odor control at the front of the plant. It was pretty much all primarily residential homeowner waste. And they treated about 1 MGD. At the very front of the plant, they had what they called an equalization tank prior to it being pumped to coarse screening grit removal. And they were generating a lot of odor complaints from this first part of the process. The plant staff often had to go down to the coarse screening grit removal area, and they would have to rake the screens to remove stuff off the screens into a container. One of the things that they would notice is sometimes they would have on bad days as much as 40 to 100 ppm of atmospheric sulfide in that room. The manager wanted to get the sulfides to less than 10 ppm, and he really wanted to target less than 5 ppm because that would allow the staff to work in the building for longer extended periods of time. They did have ventilation fans in the room, and one of the complaints they had is anytime they would turn the ventilation fans on to make it safer for the workers, they would then get odor complaints from the neighborhood because they were discharging all that hydrogen sulfide to the atmosphere, and then it would drift through the neighborhood and cause complaints. Initially, the liquid permanganate was injected into the wastewater at a really high dosage of 100 milligrams per liter. After 2 hours of treatment, the atmospheric sulfide dropped down to less than 5 ppm. The permanganate treatment was lowered to 50 milligrams per liter, and we were down to 2 to 3 ppm, and we were able to finally go down to 25 milligrams per liter, and the sulfide level stayed about 2 to 3 ppm in the atmosphere. And really that a large dose at the beginning was to get a lot of permanganate into the equalization basin so that we could turn it over quickly and get the odor knocked down immediately, and then turn back to a normal dosage to just treat the wastewater that was coming in and maintain that odor control. Based on this system, we were able to get below 5 ppm of hydrogen sulfide in the room, and it was an easy system for them to apply the permanganate directly to the wastewater coming in and knock the odor down. Our next case study here was sludge dewatering. It was a large plant treating 27 mgd of wastewater, and they daily dewatered sludge on a centrifuge. Average biosolids to the centrifuge were about 100,000 gallons per day, and they treated about 160 gallons per minute on the centrifuge, and anywhere from 2 to 2.5% wastewater solids. The biosolids going to the centrifuge were 60% primary and 40% waste-acted secondary sludge. Prior to the sludge going to the centrifuge, they had a sludge holding tank that could hold roughly 100,000 gallons per day of biosolids. So there is about 24 hours of detention time for the sludge prior to it being dewatered on the centrifuge. The issue they were encountering was the biosolids would go septic in the holding tank, and then when they would turn the holding tank on to start transferring over to the centrifuge, they would get odor complaints from both the holding tank, and then as they dewatered the sludge, they would get odor complaints. The hydrogen sulfide in the room could get as high as 50 ppm. The H2S above the centrate line would get as high as 150 to 180 ppm. And the dissolved sulfide in the centrate that was being recycled to the front of the plant was anywhere from 2 to 3 milligrams per liter being put back to the front of the plant. Worker safety for this plant was a big concern. What they did is the solution was to inject liquid CARUSOL permanganate into the sludge pump to treat the sludge going into the holding tank. A full-scale plant demonstration determined that they needed roughly 30 gallons per day of liquid permanganate, which roughly turned into about 75 milligrams per liter as sodium permanganate. By treating the sludge in the holding tank, they were able to knock the hydrogen sulfide down. In the room at the centrifuge, the hydrogen sulfide was reduced above the centrate line from 180 ppm to less than 20. The H2S in the room was reduced from 50 to an average of 0. The centrate that was being discharged back to the front of the plant went from 2 to 3 milligrams per liter of dissolved sulfide to 0 milligrams per liter of sulfide. And they also noticed because they were doing pre-treatment with the permanganate, they were seeing a slight increase in cake solids over the many months that they ran the trial and continued to do it into the future. The cake solids increased from 24 to 25% coming off of the centrifuge to about 27 to 28%. And so that saved them some hauling costs because they were hauling all their sludge to a landfill. They also noticed that when they were treating with permanganate that they were able to turn their polymer down about 40 to 50% and still see that increase in cake solids. So they were able to pay for the treatment cost of the permanganate with the increase in cake solids and some of the polymer reduction. So that was able to offset some of the cost for the odor control. Sometimes you might need another option for odor control as well in your system. In this case, it would be our CARUSOL Plus liquid permanganate. The CARUSOL Plus liquid permanganate is available, and it's a 20% combined oxidant solution. So it combines permanganate with another oxidant. It's available in both bulk and 250-gallon IBCs. And it has the same characteristic dark purple color that CARUSOL does as well. Our application for this was at a belt press site at 150 gallons per minute, and they had roughly 3 to 4% solids on the belt press itself before dewatering. They had no current treatment, but they did have odor complaints. During the trial, we tried the CARUSOL Plus at multiple dosages to try to dial in what was the best dosage. You can see that we tried 100 milligrams per liter, 75, 50, and 0, with the highest level of hydrogen sulfide directly above the belt press being about 500 to 600 ppm with no treatment. With 50 parts, we got it down to around 400. With 75 parts, we were able to get it directly above the press between 200 and 300. And then at 100 parts of CARUSOL Plus, we were able to get the atmospheric sulfide directly above the press to less than 100. What we looked at was several other factors while we were treating the belt press. With no treatment, the dissolved sulfide in the filtrate off of the belt press was about 4 milligrams per liter. Atmospheric hydrogen sulfide coming off the top of the press was 569 on average, and the peak could get as high as 600. As we increased the feed rate, we were able to drop the average dissolved sulfide to 0 with the highest dosage. We were able to knock the average sulfide coming off the top of the press to 64, and the peak atmospheric hydrogen sulfide only was 100 with the highest dosage. One of the things they kept track of is when they were dewatering, they would open over the overhead doors and all the doors to get airflow to kind of move the air around because of how stinky it could get in the room. Atmospheric levels, once we treated at the 100 milligrams per liter, became 0 in the room where the operator was operating. And sometimes when they weren't treating, they could get it as high even with the airflow. They were above 10 ppm in the room with the doors open. So it was a way for them to knock the odor down quickly, and they could vary the dosage and keep track of different things to see where the odor was and how much they needed to apply. So in summary, one of the things you want to do before you have a trial is you want to locate the sources of odors. Where are they at? Are they out in your collection system? Or are they located around a certain process in your wastewater treatment plant? If they're out in the collection system, then you want to try to minimize your detention time, have good housekeeping, keep those wet wells clean of grease, and just move the wastewater quickly to the plant to minimize the amount of chemical that you need to feed in the collection system. Once you're in the treatment plant, the faster that you can process your sludge and the less time that you hold it, you'll also have less odor complaints as well. So those are all things you should try prior to chemical treatment. Once you've eliminated all your easy options and you have to do odor control, you do have a lot of options with Carus. You can use CARUSOL liquid permanganate or CARUSOL Plus liquid permanganate, and that can be used both in the collection system and at the wastewater treatment plant itself. Generally, the cases where you use this type of product is you have really high odor complaints and you're going to treat immediately at the application point is where you want to knock it down. So you're treating at the lift station, and that's where you have the odor complaints. Or you're treating at the sludge dewatering, centrifuge, or belt press, so you're treating right there and want to eliminate it immediately. Out in the collection system, you do have some other options. If you're having a lot of odor complaints over many manholes or lift stations with long detention times, connected sites, then you might want to use TOTALOX Odor Eliminator to provide both permanganate and nitrate for long-term odor control. And you can eliminate both high odor levels and low odor levels. With the tablets, those are typically going to fit an application where you don't have any kind of facility where you can put equipment, and everything can be contained below the manhole cover. Generally, these work best when you have lower odor issues with hydrogen sulfide or lower flows. If you start to move up to things where you have flows over 100,000 gallons or approaching 1,000,000 gallons a day, just based on how much flow you have, you're going to go through the tablets quite frequently and have to replace them more often. So it makes more sense that the tablets fit into lower flow areas and places where you don't have a ton of odor issues, you just have occasional complaints. Some other products that we didn't talk about for wastewater treatment that CARUS supplies is we also have Fend Ultra Low Nutrient Removal. That product is used in the wastewater plant for total phosphorus removal, so wastewater plants can meet future discharge limits for total phosphorus that are being lowered throughout the US. We also sell a complete line of CARUS polypro polymers that can be used in your treatment plant for both clarification and sludge dewatering. Please contact a CARUS sales rep in your area, and they can help you with an odor survey and making a choice of what would be the best product for odor control or what you need to make your process run better.
Okay, thank you, Darren. At this time, we will go ahead and start taking questions. While we wait for a few more to come in, I'll go over the current slides. This one shows our sales managers along with their contact info. Like Darren said, feel free to reach out to yours in your region. And we did have a few questions come in. The first one on the pump station example by the school. The concentration of dissolved H2S was 4 to 5, which at 25 degrees Celsius, 77 degrees Fahrenheit, is about 1250 ppm atmospheric according to that graph. Does that indicate that anyone near the pump station would have respiratory tract irritation, eye injury, etc.? Was this another driver to install odor control at this station?
Yeah, so the levels that you saw in the dissolved sulfide, you had the ventilation. There's two little tiny vents on the top of the lift station, and they were only getting about 50 ppm coming out of the vent. And then obviously, since you're outside, that expands in the air, and so it becomes much lower. We were seeing higher levels down in the wet well itself, but you don't generally go in there unless you have to work on a pump. And then they would put forced ventilation in it. So really what their two kind of goals were, well, the big one was they had just replaced the pump station for the corrosion issue, and it had done that epoxy paint to kind of protect the concrete. And then they were still getting odor complaints even when they did that from the school. So that was really most of the impetus was we don't want to have to replace all the equipment here at the wet well from corrosion again. And we're still getting all these odor complaints from the school district. If you went to the front of the school, one of the things they also did was they had walked around with sulfide monitors in front of the school, and the monitors that they use generally don't detect lower levels, and they never got a hit, but you could definitely smell the rotten egg odor in front of the school. So they probably needed a small monitor there, but it was all based around the odor complaints at the school and the corrosion issue. The worker safety they could work around if they had to get into the wet well by ventilating it. So.
Okay, and then we had another one come in. Is there a difference between how potassium permanganate and sodium permanganate work for odor control in wastewater?
No, it's just kind of the form of permanganate that you want to handle. So CAIROX potassium permanganate has to be mixed up into solution typically prior to you applying it. So you'll have to have a piece of feed equipment at the pump station, and then also have to have a water source to mix it into solution prior to applying it. Whereas the CARUSOL sodium permanganate can be fed directly out of the container at the source with just a metering pump. So it's just a little bit more equipment that you need for the dry permanganate. We still have a lot of customers that use dry permanganate out in the collection systems with small feed systems to apply it. But the reaction rates are the same, whether it's CARUSOL or CAIROX potassium sodium permanganate. It's the same amount that you're going to need. It's just the form that you're using and what type of equipment you have.
Okay, perfect. I think that's all the questions for now. So thank you again, Darren, and thank you everyone who tuned in to watch. Have a great day.